Now it's your turn to try the online activity found at the NASA Connect website. Your challenge is to get the PSA to the overheated racks before the time runs out. Each click gives the PSA 1 unit of force in the direction of the arrows. Remember Newton's law. The PSA will keep moving unless you apply another force to it in the opposite direction. Your teacher will now pause the program so that you can go to your computers and check out the activity.
I gave the PSA too much force. It hit the side of the ISS.
The PSA keeps moving after you have applied a force to it.
You have to apply a force in the opposite direction to stop the PSA.
Newton also had something to say about motion and the mass of objects. The more massive an object is, the more force is required to accelerate it or to stop it.
So if the PSA is very massive, for instance, it's going to take a lot of force to get it moving and a lot of force to stop it.
You're right. The greater the mass of the PSA, the more force it takes to slow it down. The fans have to work harder. If we make the PSA lighter, it requires less force to slow it down than to stop it. If the PSA was going to go too fast, it might bump into the side of the ISS. So we need to make the PSA as light as possible. The current model that you see here is the 12-inch working prototype. Our goal is to reduce the PSA size down to this 8-inch diameter model. With the invention of the transistor, computers and other electronic gadgets became smaller and smaller.
Oh, that's right. You know, when our grandparents were kids, they listened to radios that were like large pieces of furniture. Today, radios and digital players are really tiny.
That's right. A computer with the same power as this PDA filled this huge room. The PSA has a computer inside it, and in addition, the PSA can connect to computers on the space station or on Earth with a wireless connection and use the computing power of those computers.
So the PSA can be small because it doesn't need a big computer inside of it. But why is it round? And how do you make the shell round?
Round shapes don't have any sharp corners, so the PSA won't accidentally damage the ISS. We designed the round shell with a computer program for solid modeling. Once the design is complete, we send an electronic file to the manufacturer to create a shell. The process is called stereolithography, or SLA. To make the PSA smaller, we need to redesign and shrink the parts in the PSA so that they fit into a smaller sphere.
Oh, wait a minute. I don't know if that's the best way to do it.
When we make things smaller, though, we have to keep some things in mind. For example, the computer that's in the PSA needs to have space around it so that it can stay cool. The computer gives off its heat from the surface area of the board, which means we need to provide space for cooling. Additionally, when we consider shrinking the fans to fit in a smaller PSA, we discovered they became very inefficient, forcing us to move to a blower design. It's similar to how a leaf blower works.
Okay guys, let's review some math concepts so you can figure out how to fit your parts into the PSA. This is a rectangular prism. Now each one of its 6 sides is a rectangle. The surface area of the rectangular prism is the sum of the areas of the 6 sides. The volume of a rectangular prism is the area of the base times the height of the prism. Let's take a look at cylinders. The base of a cylinder is a circle. Let's take a look at the parts of a circle. The circumference is the distance around a circle. The radius is the distance from the center of a circle to any point on the circle. The diameter of a circle is twice the radius. Thousands of years ago, mathematicians measured the circumference of circles and divided the circumference by the diameter. They always came up with the same number, around 3.14. This number is called pi. Now, watch this and see how we can find the area of a circle. We cut up the circle and move the pieces around. Now the area is the width times the height. The width is pi times the radius, and the height is the radius. The surface area of a cylinder is the sum of the areas of the 2 circles and the area of the side, which is really a rectangle. The volume of a cylinder is the area of the circle times the height of the cylinder. Now, here's the challenge. Find the length, height, and width of a rectangular prism that has a volume of 24 cubic inches, fits into an 8-inch PSA, and has as much surface area as possible. Find out whether a tall cylinder or a wide cylinder has more surface area when the volume stays the same. You can download the files for this activity from the NASA Connect website. It's now time for your teacher to pause the program so you can take the challenge. Use your imagination, draw figures, take measurements, and do calculations.